Imagine that somewhere over the Pacific Ocean, at an altitude of 400 kilometers, a nuclear bomb just detonated. Yield 1 megaton. For comparison, that is roughly 70 bombs of the kind dropped on Hiroshima. And here's the strange part. You are standing on the ground and you see nothing. No mushroom cloud rising above the horizon, no blast waves shattering windows, no thermal radiation setting buildings on fire, no destruction. Just a flash in the upper atmosphere, bright and unusual, resembling an unusually intense aurora. And that is it. You look at the sky and think, nothing happened. But the catastrophe has already occurred. You just have not felt it yet. To understand what happened, you need to understand one physical effect: the electromagnetic pulse. When a nuclear bomb detonates in the air or on the ground, it produces an electromagnetic pulse, but most of it is absorbed by the atmosphere. Air acts as a shield. When the same bomb detonates in space, that shield is gone. Gamma radiation from the explosion travels downward and slams into the upper layers of the atmosphere at altitudes of 20 to 40 kilometers. There it knocks billions of electrons out of air molecules, and those electrons are accelerated by Earth's magnetic field, generating a powerful electromagnetic pulse that propagates downward at the speed of light. The affected area from a detonation at 400 kilometers altitude covers approximately 8 million square kilometers. That is larger than all of Western Europe, or most of the continental United States, in a fraction of a second. Any device connected to the power grid or containing electronic components within the affected zone receives a voltage spike of thousands of volts. Transistors burn out instantly. Microchips fail. Everything that ran on electricity stops working, permanently. If you think losing electronics is an inconvenience, subscribe, because the next 30 seconds will explain why this is the end of the world as you know it. The first seconds after the detonation, hundreds of aircraft are in the air above the affected zone. Commercial airliners, military planes, cargo jets. A modern aircraft is a flying computer. Flight control systems, engines, navigation, ground communications, all of it is electronics. The moment the electromagnetic pulse hits, onboard systems fail simultaneously across every aircraft in the affected zone. Pilots lose control in a fraction of a second. Some aircraft equipped with backup analog systems have a chance. Newer ones do not. Hundreds of planes begin uncontrolled descent simultaneously. Hospitals switch to backup generators, but generators also have electronic control units, and those have failed too. Intensive care units, operating rooms, life support machines, all of it shuts off in the same second. Military command centers go blind. Radar, communication systems, computers, all dead. The armed forces of the major military powers within the affected zone are reduced in 30 seconds from coordinated fighting forces to armed people with no communications and no coordination. The internet disappears not because cables are cut, but because routers, servers, and switches across the entire zone burned out simultaneously. Financial markets stop not because traders decided to halt trading, but because exchange servers are physically dead. All of this happens in less time than it takes to say the word catastrophe. But the electromagnetic pulse is only the first blow. The second one unfolds over months. A nuclear detonation in space does something else. It injects an enormous quantity of high-energy particles into Earth's radiation belts, the zones of magnetic field that normally hold charged particles from the sun in place. After the detonation, these belts become recharged to levels hundreds of times above normal, and they begin methodically destroying satellites. A satellite in low orbit passes through the intensified radiation belt on every loop around Earth. Each pass damages its electronics. Satellites designed to operate for 10 to 15 years begin failing within weeks. First the communications satellites, then the GPS and GLONASS navigation systems, then the meteorological satellites, then the reconnaissance satellites. This does not happen instantly. It is a drawn-out catastrophe that unfolds over months as Earth's entire satellite fleet gradually degrades and goes silent, one by one. A real historical example, the American Starfish Prime operation in 1962. The detonation of a hydrogen bomb at 400 kilometers altitude over the Pacific Ocean knocked out several satellites over a period of months. And that was a 1.4 megaton bomb, at a time when the orbital satellite density was a fraction of what it is today. Today, there are more than 8,000 active satellites in orbit. What the world looks like afterward. The affected zone, roughly the size of Western Europe or most of the United States, lives without electricity. Not like a regular power outage where you wait a few hours and the lights come back. Transformers, generators, power stations, all equipment with electronic components requires replacement. Not repair, replacement. Because burned-out microchips cannot be fixed. High-voltage transformers are custom manufactured and delivered over months. Restoring the power grid of an affected zone is years of work, not weeks. Without electricity, there are no refrigerators, and food spoils within days. No pumps means no water supply. No communications means no coordination of relief efforts. Medicine reverts by decades, limited to whatever works without electronics. Transportation is reduced to older vehicles without electronic control units. The financial system of the region is frozen. ATMs are dead, payment terminals are dead. The economy instantly reverts to cash for those who manage to withdraw it before the detonation. Recovery will not take months. According to estimates from the United States Electromagnetic Pulse Commission, depending on the scale of the event and the preparedness of the country, recovery takes anywhere from 1 year to 10 years. The most frightening thing about this scenario is not the explosion itself. Nobody saw the explosion. Nobody felt a blast wave. There was no fire falling from the sky. There was just a flash on the horizon that looked like an aurora. And then silence. And then everything stopped working. Physics does not warn you. It simply acts. If you want to see more breakdowns like this, hit like.